Okay. Can somebody just close the door? So today we're gonna learn one more new topic or a protocol that is called NAT. So Murali, what is NAT? Do you know? Uniform Network Automation. Network automation, okay. Then T stands for network automation translation. Good. Yeah. No, according to him. What are you doing there? Yeah. Today we're gonna learn something about the NAT. NAT means what? Network address translation. Okay, and you already know that the internet can't understand private IP addresses. Okay, and your system's internal network they can't understand public addresses. So that is the reason what we do just to translate from this public to private and private to public. Okay, we have a protocol called a translation protocol called NAT. Okay, you can see here a NAT is a networking process used to modify the IP address or IP address information in the packet header as they traverse a router or a firewall. Okay, they have to go through this router or a firewall to reach the internet. Okay, so that is the reason it will enable us or the devices on a private network to communicate with the external network, just like the internet, using the single public IP address or a pool of public IP address. So what we do here, we just map. If somebody asks you what exactly the NAT is, you can say that it is a mapping of private IP addresses to public IP addresses. Private IPs to public IP address and vice versa. Okay, why vice versa? Because if they get back with any reply, so, okay, they have to talk with the same private IP address what it has mapped with. Okay, so that is the reason we can say that what it is a mapping of what private IP addresses to the public IP addresses. Yes. And why exactly we need this NAT? So because of this IP version 4 address shortage, I think we discussed already about the IP version 6, right? So there also we studied that this NAT was used for the short term, what do you call, option for this word. Oh, you say, oh, sorry, yeah, use of this IP version 4. Okay, just to save them. Yes. So, but that was a short term option only. Again, the long term it will goes with the same IP version 6. Okay. So IP version 4 offers approximately 4.3 billion unique addresses. With the explosive growth of the devices, the number of available IP addresses are totally insufficient. I mean, I'm talking about in version 4. Okay. So this is a major reason behind using this translation, and then it will help us for network security also. Like how NAT it's gonna hide internal IP addresses. I mean, private IP addresses they are not going to internet. Okay, instead of that, one public IP address will be going to the internet, and yeah, this is what the request I got. Okay, from this, but I mean, one private IP address. Okay, I just want the reply. Yes. So making it harder for external attackers to directly target internal devices. So what happened? Let's suppose like Murali wants to talk with someone else who is standing outside. Okay. So what he thoughts like just for the security reason, he will not go outside. So what he'll do, whatever the request he is having, okay, he'll just give it to Jeet. So what Jeet will do, he'll just go to outside network and he will get back with a reply. And you will be giving it to the Murali. So this is kind of what a NAT process. Okay. So Murali is being what? He is a private address and you are a public IP address and you are a face of him. Okay. So Jit will become the face of this Murali. Okay. So he'll be taking the request of him. So like this, it's gonna hide the internal network. Okay, it's gonna hide the private network by facing the internet or the public network, I can say, or the ISP one. Yes. So it will simplify the routing. Why? Because the whole private network, they are not going to go to the public or internet. Okay, only the public IP addresses will go, and only that you should route. Understood? So NAT allows the multiple devices to share a single IP address, simplifying the routing and administration. So here in NAT, we have some three types. One is what? A static NAT, and second one is a dynamic. And in the same, we have one more that is called as what? Port address translation. Okay. So in static NAT, one-to-one mapping will be there. And in dynamic NAT, one to a pool of IP addresses mapping will be there. And here, PAT, it is many to one. Many means what? Many will be private IP addresses, and only one public IP address will be taking the whole traffic of this, all the traffic, sorry, private IP addresses traffic. Okay. So that is the reason you don't need to, what do you call, route all those public IP addresses. If you have only one public IP address, and if you're using a port address translation, you just need to give only one routing protocol. Sorry, only one route should be routed towards the internet. Okay. So instead of doing the one-to-one or a one-to pool of IP addresses. Clear? So the same thing I said you, static and dynamic and the port address translation. And the first one is what? Static NAT. So I hope I already said you what exactly this one is. What is a static NAT? Here statically we are going to map one private IP address to the one public IP address. Okay. So static NAT is one-to-one mapping between private IP address, that is nothing but, it is also called as what? Inside local, and a public IP address, that is also called as what? Inside global. So this mapping is fixed and does not change, ensuring that specific internal devices always use the same public IP address for the communication with the external network. Okay, for example, if you take this one, so my private network is what? 10.1.1.1. Okay, and to this one, I'm going to give one public IP address. Let's say 200.1.1.1. Okay, and this 10.1.1.1, if it wants to talk with internet, always, and if you are configured with the static one, it always go and reach whom? 200. Yes, 200. I just want to talk with the internet. Okay, so this is my request. Just take this one and give me back with the reply. Okay, so the 200 will take that request and it will reach the internet and it will get back with a reply. And it already maintained, this routers will maintain NAT table. What they will maintain? NAT table. And it will already there to which private IP address, which public IP address is mapped. Okay, so it already see that like for 200.1.1.1, this public IP address, sorry, private IP address map, that is a 10.1.1.1. So it's gonna give that reply to the 10.1.1.1. So this is how it works in the static one. Okay, I mean, it's totally fixed until the administrator changes it. Okay, it is totally fixed. It never go to 200.1.1.2. Okay, 1.1.3. No, it is already given statically that the 10.1.1.1 should go through 200.1.1.1 towards the internet. It has to go through the same IP address only. Okay. So some key features of this NAT, I mean the static NAT, it is a one-to-one mapping. I mean each private IP address is mapped to a single or a specific public IP address. Okay. So for example, this one 192.168.1.0, it's a 1.10, it's a private network, and this is mapped with whom? 203.0.113.10. It's a public IP address. I hope you know that ranges of the private and public. Yes? Yes, Abhishek? Can you just tell me the private IP address range? Yes, Parthi? In class A. In class A. Pratik. 10.25.25.255. Okay. And in class B? 168. Okay, so these are what? The private IP addresses. Okay, they are not internet facing IP addresses. Okay, so just to take the request of these private IP addresses towards the internet, we need both public IP addresses. Okay, other than this, do we have any other range that will not be given to the internet? Loopback addresses, then APIPA is also there. Okay, and then multicast address, and then the class D and class E addresses. Okay, yeah. So here here I was private to public. It's a one-to-one mapping. Yes, and it's a permanent mapping. That means the mapping is static, meaning it is manually configured and remains constant until explicitly changed by the administrator. Okay, what will happen? Who is that? Okay. So as I said, it's a permanent mapping until the administrator changes it. It will be the same that whatever the private to public IP address mapping will be done. So that will be seen until it will be changed. So next is it's a bidirectional communication. Like external devices can initiate the communication with the internal device using the public IP address, making it suitable for hosting servers like web server, email, or a FTP server. So basically, what happened? Nowadays we are not using the static NAT. Okay, why? Because if I'm having 10 numbers of private IP addresses, then how many I need public IP addresses? And let me tell you, private are free, but public should be, they are brought. You have to buy them, okay, by paying money. Okay, so that is the reason we can't afford this static NATing. Yes, if you have any, okay, in that case, if you have any kind of a server will be hosting in your network. In that case, you can give what? The static netting. Always it will be having the same IP address. Okay. So this kind of a scenario, we can use what? This static netting. So other than this static netting is not it's not usable. Okay. So how exactly this works now? Static net. So we have two kinds of traffic here. One is the outbound traffic and second one is the inbound traffic. Okay, what is this? Whenever an internal device sends the data, okay, whenever an internal device sends the data, so that will, I mean, the NAT will changes the source IP address from 192.168.1.0 to the mapped public IP address 203.0.113.10 before forwarding it to the internet. I mean, whatever the data which is going outside of your network, okay, by changing your private to the public IP address. So this is called as what? Outbound traffic. Okay. And whenever the reply comes back, whenever the reply comes back from the internet or over the external network, okay, that is called as what? Inbound traffic. Yes, you can see here. Whenever the external device sends the data to the public IP address, that is 203.0.113.10. Okay, so this NAT translates the destination IP back to the private IP address and forward it to the internal device. So with the help of which table I said? With the help of the NAT table, it's going to understand that to which private IP address, which public IP address will be, I mean, is mapped here. Okay, so to the same, I should forward the data. Understood? So that is the reason this NAT table is really important here to send the data from external network to the internal devices. Yes. So this is the configuration. We will do it later. So next is dynamic NAT. So it's kind of what? It's kind of a DHCP, I can say. What we are seeing in the DHCP? What you are seeing in the DHCP? Whatever the pool will be giving, whatever the available IP address will be there, that will be assigned to the client devices. So here also we'll be doing the same thing. We will be we'll be giving the pool of public IP addresses, and whatever the pool of public IP address will be remaining in the pool, and that will be assigned to the private IP address when it wants to talk with the internet or the external network, I can say. Yes. Sorry. One to one, but not statically. It's dynamically. Okay. It's kind of what? Yeah, it is one to one, but not fixed. It's not fixed like a static one where always this standout.1.1 will be reaching the 200.1.1.1. No. So let's suppose like we have given the pool of IP address that is 200.1.1.1, okay, up to 200.1.1.5. Done. So let's suppose I have some 10 private IP addresses. Okay, let's suppose like 10.1.1.1 to you can say 1.10. Okay. Now this time if the 1.3 wants to talk with the internet, 1.3 wants to talk with the internet, what it will do? It will go and check the pool. It will ask, is there any public IP address which is available? I just want to talk with the external device or external network. So pool will say that, yeah, 200.1.1.2 is remaining. I mean, it's free. You can take this one. So the same will be maintained in the NAT table. Okay. Once the 200.1.1.2 will be coming back with a reply. Okay. It will give it back to the 10.1.1.3. Okay. Then it is free now. It will be released back to the pool. It is not like it is permanently assigned to the 10.1.1.3. No. Once it comes back with a reply to the 10.1.1.3, that will be released and again given back to the pool. And again, that may be assigned with any other private IP address. This is called as dynamically. It is going to choose one from the pool. Okay. So it's a method of translating a private IP address to a pool of public IP address dynamically. Unlike static NAT, which provides a fixed one-to-one mapping, this dynamic is going to assign an available public IP address from pre-configured pool pool whenever a private IP requests to access the outside network. I mean, it's not like every device they are going to talk with the internet at the same time. No. Okay. So one of the either of them will be idle, or they are not going to talk with the internet. Okay. Now you guys are really sitting quiet. Are you talking with the internet or no? No, right? So in this time, if they are using the pool of public IP addresses, that may be assigned with any other private IP addresses. So this kind of thing. Okay. So how exactly this works is, so here also we have some dynamic assignment. So here private IP addresses are assigned to a public IPs on a demand from a pool of available addresses. Again, it goes on a demand. If the private wants to talk with the internet or external network, then only that will be assigned with the available public IP address. So don't forget this word, available public IP address, because you can't assign any IP address. Okay. So let's suppose 200.1.1.1 is already assigned with the 1.1.2, let's suppose. Okay. So you can't give that one, because for that one, for that record, that only you will be maintaining the NAT table. Okay. So that's the reason you have to mention this available IP address. And even in the DHCP also, there also it will give what? Available IP address in the pool. Okay. So once the session ends, the assigned public IP address will become available for the other private IP addresses. Understood? It's kind of like now in static, what I said you, if you want to talk with the outside world, you will go to the G. Okay, and nobody will use him to talk with the other world. Only you will be giving your request to him, and he will be taking it to the other world. And now this time he will be available to everyone. If him want to talk with the outside world, okay, he will take his request and he will come back. Again, you want to talk, then again he will take yours, like this. Okay, again it goes on the availability of the IP addresses in the pool. Yes. And it's a many to many mapping. What do you mean many to many? Exactly. It will allows the multiple private IP address to map to a range of public IP address. Range means what? Again, the pool what you are given. Okay. So it's not fixed as such. Yes. So that is the reason they say it like what? Many to many mapping. Yes. But the number of concurrent translation is limited by the size of the pool. Again, it's totally depends on how much pool, IP addresses you are giving in a pool. Yes, if you are having a 10 private IP addresses, then you can give 5 public IP addresses. That will be enough. Okay. So at least you are saving some 5 public IP addresses as compared to what? Yeah. Static one. Okay. And it is non-persistent. What do you mean by this one? Mapping is not a fixed one. Okay, like they last only for the duration of the session. Once the session ends, then again it will be given back to the pool here. Yes, so that is that's the reason they call it as a non-persistent. And how exactly this dynamic NAT works here? So here also we have the same outbound traffic and inbound traffic. What is outbound traffic, Swayam? Outgoing. Okay, and then inbound, incoming. Outbound traffic, whenever an internal device sends a packet to an external network, the NAT assigns it available public IP address from the pool and update that NAT table. Okay, what it will do? It will check the pool. Okay, so this particular network wants to talk with the, or a private IP address want to talk with Yeah, what I said, what I was talking about. Outbound. Hmm. It's a central request by the after sending the public address, it's located in. Whenever the private pages want to talk with the network, okay, it will check for what? Is there any public IP address which is available in the pool? Okay, so if it is all available, then it will be assigned. If it is not, so it will be said that please wait for that. So that's the reason it will say that what? It is not reachable sometimes. Yes, if it is using what? Dynamic. And the same will be maintained in the NAT address table. Okay, sorry, NAT table. Next is what? Inbound traffic. Again, if you are sending the request, then the response should be coming back. Yes. So once the response to the original outbound request are matched against the NAT table, then that will be routed back to the correct private IP address. Again, with the help of this NAT table, it's going to route that particular traffic back to the actual device where it requested it. Yes. So here the IP reuse can happen. Like once the session ends, the public IP address will be released back to the pool of public IP address for the reusing purpose. That can be assigned with any other private IP addresses here. Clear? And this is the configuration. We'll see it later. And the last one is what? PAT. Yeah, what is PAT? Port address translation. Yeah, port address translation is also known as what? NAT overload. It is also called as what? NAT overload. Here, it is a type of network address translation that allows multiple devices on a private network to share a single public IP address. Okay, so it is not like a static one or a dynamic one. What we are given in the static one, it was totally like a one-to-one mapping, and the dynamic one, it is a many-to-many. Okay, and this one is many-to-one. What do you mean by many-to-one? Many private IP addresses and only one public IP address will be there. The whole private IP address traffic will be given to only one public IP address. But the difference you can see that is in a port number. Port number. Okay. So this part will achieve this by using the unique port numbers to differentiate each device's communication. Okay. For example, if you are using this part, and nowadays this is the only NAT protocol is being used. Okay. For example, let's suppose you have 10.1.1. Okay. Let's suppose we have this kind of private IP addresses. And what will happen to this one? Let's suppose 50.1.1.1. Okay. To this also 50.1.1.2. Same 50.1.1.3. And here 50.1.1.4. And here 50. Array, what I was trying. So public IP address will be same. Okay, sorry for that. So here the difference is what? The private IP addresses are different. Okay, and what is the public IP address? It is same. So difference you can find it is in a port number. It will be adding a separate port number to every private IP address and a public IP address. Let's suppose here it is giving 1001, 1002, 1003. It will take random one. Okay. Whatever the available port number will be there, that will be assigned here. It is just for example. So in this case, what you have to do, you have to buy only one public IP address. Okay. Through the same, you are going to send the whole private IP address traffic towards the internet or to the external. But the changes you can see in what? This port numbers. And this is very important, and that will be noted into the NAT table. Okay, so that's what they said here. It's going to achieve by using what? A unique port number. Okay, that is going to differentiate each device's communication or the traffic. Understood? So what are those features? Port, it's a port-based translation. Yes, Mayur, you want access? Okay, each internal device is identified by the combination of its private IP address and the port number. That's what I said. Here combination will be there. Like what? Not only public, sorry, private to public IP address. Here it will be the private and the port number, and then what? Public and the port number. So this is how it's going to differentiate what? The traffic here. Okay, differentiate the mapping asset. So private to public IP address mapping. So PAT is going to assign a unique source port number to every connection to distinguish sessions. Mayur, what are you doing? Okay, here it is what? One, two, many mapping, like multiple private IP addresses are mapped to a single public IP address, but the difference you can see in a port numbers. So here you can use the IPs really efficient. Okay, why? I mean, how we are going to conserve the public IP addresses by allowing many devices to share a single public IP address here. Okay. So how it exactly works? Again, the same outbound traffic and the inbound traffic. The major difference you can see is again what? The combination of it. Private to private and the port number, and the public and the port number here. Okay. So a private device sends the data to an external device or a network. The router replaces a private IP and a port number with a public IP and a unique port number. Okay. So the translation is recorded into NAT table, and the inbound traffic, the external network respond to the public IP address, and the router checks the NAT table, and it's going to identify the corresponding private IP and the port number, and then it's going to forward back to the correct internal device. Okay, so this is how the PAT works. Clear? So let's go to this PPT. Uh, So this is what the scenario I have. Okay, so these are my local area network, and I just want to reach this server which is there somewhere in the internet. Okay, so I have done which routing here. If I want to talk with the internet, which routing I may use? I have to use a default routing, and while coming back, I can use a static route. Okay, you can see the same thing here. IP route 0.0.0.0 space 0.0.0.0. That means what? Any IP address with any subnet mask, you have to go and reach whom? 100.1.1.2. Okay, so that same is assigned on this one 100.1.1.2. Okay, and here I have assigned 192.168.1.0 network, and here I have assigned a 200.0 network. And while coming back, what I said, you have to use a public IP address that is called as what? 50. Okay, 50 will be the 50 network will be the public IP address format. Yes. So this is what the configuration are already here. And if you go with the first one, static NAT, what you have to do first? First you have to decide which is a inside NAT and which is a outside NAT. Okay, I mean which interface will be taking your outside traffic and it will be taking your traffic inside the network. Okay, so can you just tell me like which can be inside and which can be outside? Mhm. So this is what the outside NAT and this is what the inside NAT, because this is where it is going to take your traffic towards the external network, and when it coming back, this is an interface where it is taking inside the local area network. That is the reason this is the inside and this is the outside NAT. Okay, so now we'll go with the static NAT. It's very simple, nothing is there. We have to say IP NAT, let's say question mark, it says that inside, outside, or a pool. Okay, so I have to say it is the inside, and then if I say question mark, it's a source. Okay, which is source. Source IP address is what? I mean, now I'm not giving any list of this one, so that's the reason I'm going to go for what? Static one. And if I after that, it will ask me for what? What is the inside local IP address? Inside local IP address. So that is 192.168.1.1. So let me confirm. Yeah, 1.1. And then if I say question mark again, it will be asking me what? Inside global IP address. Global IP address means what? Which will be taking your request towards the internet. Okay. So that will be, in my case, I said I'm going to use 50.1.1.1. Okay. Done. So just say enter. So this is for the first one. And for second one, it will be 2. And this will also be. And for third one, 3. Done. IP NAT inside, source static. Okay. In pool, you are going to give the pool here. Yes, instead of static. Yeah. Don't worry. Okay. Now let's go and ping the 200.1.1.1, I guess. Yeah. It's pinging. So other server is pinging. Okay. So let's go and check the NAT translation here. So do show NAT translations. What is that? So what it says? Which protocol it is taking? Why? Why it is taking ICMP? Because I said ping, right? Ping means what? It's the ICMP packet. Okay. Why it sent 8 packets? Opcode. Okay. Before that, can you see this one? 50.1.1.1 is mapped with the internal or inside local. Inside local means what? Your private IP address. And inside global means what? The public IP address will be taking your traffic. Okay. In this case, it's a 50 network. And your inside local is what? 192.168.1.0 network. Okay. So 192.168.1.1 will be mapped with the 50.1.1.1 and 1.2 will be with the 50.1.1.2 and 1.3 1.1.3. Okay. So here this is the request and the reply packets. Okay. So inside global it is showing what? 50.1.1.1. Inside local 192.168.1.1.1. So this side we are not connected with the actual network or internet. So that is the reason you may see both outside local and the outside global as the same 200.1.1.1. Okay. In the actual network, okay, there may be a lot of what do you call IP addresses will be there. Yes. On the other end, whatever the netting process will be taking place. So there it will be maintaining the same here. So here it will be like the outside whatever the public IP address it will be using. Okay. And at this end, global, it will be using a public, and at the local, it will be using the private IP addresses. Okay. Okay, Murali. Do you think now this last PC is going to talk with the 200.1.1.1? Sure. Yes, because it's not conflict. It's not going to talk. Why? Because I just mapped only 3 IP addresses. 1.1, 1.2, and 1.3. Okay. So that means even though if you're having the connectivity between these, okay, so the translation is not working here. Yes, so that is the reason this last piece is not able to talk with the other end. Okay, to the external world. Okay, now one more traffic. Yeah, where did all this gone? Can you say only one? TCP. What is TCP? I generated a HTTP traffic from this end to the other end. Okay, and even it is getting the reply. And from where it is going? From it is going from 192.168.1.3. Okay, with the help of 50.1.1.3. Okay, and even you can see what the port numbers. What is the port number of HTTP? 80, and this is a random one. Okay. Yes, Mayur. Very okay. You can see here the statistics. Okay, so three static nats are done. Okay, and outside net is, who is the outside net? Which interface? 0/1, and inside net it's a 0/0. How many hits are there total? 13. Okay, I mean this 3. Okay, and this one 4, and that 8 or 8, yeah, 8. Okay, so how many got expired? 8 already got expired. This NAT table doesn't keep all those transaction what is happening here. Okay, so by the time it's gonna expire all those transactions. Okay, what's happening? So that's the reason you can able to see only this TCP, only one. Okay, so if you check it once again, after some time it will also be gone here. Okay, that will be removed. Okay, so this is what the static NAT. Yes. So let's go and do the dynamic one. In dynamic, it's a bit different. Okay, how is that? You have to give the ACL. What ACL? What is ACL? Okay, what is access control list? I think we studied yesterday only, right? It's so fast to forget everything, right? Yeah, first thing again, we have to define what inside and outside interface. Okay, that's the same. We already done with that one. So don't need to change that one. And then you have to go for what? Configuring the NAT pool. What you have to do? You have to configure the NAT pool. And after that, you have to say what I have to allow here. Okay, which pool, which private apparatus I have to allow here. And after that, you have to give what? Or associate both this NAT pool with the ACL. Okay, and that will be done. So let's go on the router. First, we have to remove this. Do I have that? Okay, done. So now you have to go what? You have to go for the configuring the NAT pool here. Yes. So how to do that one? IP NAT pool you have to say. So just take this router here. You have what? Inside, outside, and the pool here. So just go for pool, and after that, if I say question mark, it will be asking me a pool name. Okay. Just give it as a Cisco. And then if I say question mark again, it will be asking me like what? What is starting IP address of that pool? Okay. Which pool I have to give? The private or a public? Obviously, I have to give the public one. Okay. So now this time I have 3, then let me give only 2 IP addresses. 50.1.1.2. Okay. If you say question mark after this, it will be giving you what? And IP address. So that is the reason I have given 50.1.1.2. Okay. If you do have anything, net mask, what is net mask? What is net mask? Subnet mask. Enter. Okay. After that, you have to create what? Access list. Access list, it's a standard. Okay, let's go with the standard one. One, and then you have to give the permit list. Permit what? Permit 192.168.1.0 network. That's it. After that, you have to give the wildcard mask 0.0.0.255, and that is it. Just say enter. Now we have to associate both these two. Associate what? The ACL and the pool what you have created. Okay, by saying what? IP NAT inside source list. Okay, so IP NAT inside source list. List is what? 1, and then the pool is what? Cisco. That is done. Okay, first thing what you have to do, we have to create the pool. Okay, and then how you can create the pool? You just need to say what? IP NAT pool, and you have to give the name of that pool, and then you have to give the starting range of that pool. Okay, and then after that you have to give the ending, and after that you have to give the subnet mask, and after that you have to go forward configuring the ACL. Okay, I mean which traffic you want to permit here. Yes, so access list 1, and then permit whatever the network you want to permit here. In this case, it is a 192.168.1.0, and with this ACL, you always know that wildcard mask will be there. Okay, you have to give the wildcard mask. So after creating this pool and the ACL, you have to combine both this. Okay, then only this will be working there. Okay, so let's go and check it. It again. It's pinging. So let's go to 0 router 0. And if I say do show IP NAT translations, it will say that. What it says, I'm taking 192.168.1.1. Okay, because the traffic is coming from what is the inside local 192.168.1.1. Which IP address is taking 50.1.1.1. Can you see that TCP translation here now? Whatever I had done it before. Understood? So this is, it's gonna what? Remove that one. It's gonna expire that translation. Okay. If we do it again, you can see the same, whatever the 4 we have here. Okay. If you go with the second one, if I say ping here, ping what? 200. It will be pinging. So let's go here. And if we say the translation, now it removed that one, removed this. Okay. And it is now giving what? 1.2. Okay. So immediately go to the third PC, PC3, just say 200. Now this time if you say the translation, which IP address is using 1.4, which IP address is using 50.1.1.1. So this is available. Initially 1.1 was given to whom? 192.168.1.1. Okay, and now this 1.4 is having whom? 50.1.1.1. Okay, and if you check it again, okay, it will be the same. Again, after some time, it's gonna expire. Okay, if you go here, do you think it's gonna take now? Sure. It's not a static one. It's a dynamic. If I say again, says that. Okay, I think I done it on this one. Okay. So ping 200.1.1.1. That will be pinging. Let's go to this and check. Yeah, again, 1.4 is using whom? 1.1 and 1.3 is using 1.2. Okay. So 1.2 was used by whom? 192.168.1.2. Okay. So that means whatever the IP address which will be available in the pool, that will be assigned to the private IP addresses. Okay. How many IP addresses are given in the pool? Only two. 1.1 and 1.2. Okay. And the same IP addresses will be being used here. So initially 192.168.1.1 was using the 50.1.1.1. So after the transaction ends or a session ends, what it has done? It is given back to the same pool here. And again, that will be assigned to the 1.4 here. Understood? The same we can see here also. Everything. 1.1 again assigned back to the 1.4. And 1.2 or like 50.1.1.2 is assigned back to the 192.168.1.3. Okay, again it will be going on whatever the availability what we have. Clear? And the last one is what? Pat. Pat is also same, but the thing is like you have to add a word called overload. That will be it. Okay, what is that? You have to give a word called overload. Before that, you can't give the whole pool. Now I have given two IP addresses, 50.1.1.1 and 50.1.1.2. And in this case, I have to give only one. Okay. Okay, now what is configuration? First thing what you have to do, we have to create a pool, or even you can go for the access list also. Okay, so create a ACL access list and then give the access list number and then permit it, whatever the IP address you want to, and then you have to give the wildcard mask. And after that, you have to create a pool and then you have to configure PAT with using the NAT. Yes, so let's go to this router 0 and then just say access list 10 this time and the permit what 192.168.1.0. Okay, just enter and then we have to go with the IP pool, IP NAT pool. This time it will like a CCNA, and then the pool will be starting at the IP address will be 50.1.1.1, and even this ending IP address will be the same 50.1.1.1. Okay, and after this you have to say the net mask, that is 255.255.255.0. Okay, yeah, done. Okay, and after that you have to say what? To configure this part using the NAT. That means you have to combine this ACL and the pool what you created. Okay, and you have to at the end you have to say what overload. Then only it will be working as what pat here. Okay, so IP NAT inside source list. What is the list? 10, and after that you have to give the full name, that is a CCNA, and then you have to say overload. That is done. Okay, so let's get back to the species. This is 0, generate on some traffic. Hmm? Only host I have given. Hmm? I just taken the host. Okay, no. This is 10, I think. Yeah. This is 10 permit 100.168.1.0. Jojo fun. Yeah, it's taking host. Yeah, the host. Mm, NAT site host. There could no. Couldn't laugh. Okay, let me check this one. I will do it tomorrow. Okay. Why to waste time? It is every host only. 1.0 it's right. But it's taking 1.0 every host. It's okay. Let me check. Okay. Tomorrow, please let me know that one. Okay. Okay, we have two attacks. Okay, on the layer 2. Okay, with the help of some DSCP and ARP. Okay, we have two attacks. We have to study that one. First one is what? DSP spoofing. And the second one is what? ARP spoofing. Or even you can call it as what? ARP poisoning. Okay, so these are the two attacks what we have. Okay, to mitigate these two, we have two solutions like DHCP snooping, and for this we have dynamic ARP inspection. Okay, so we have to study both. Now let's see what exactly that one is. Okay, so DSP spoofing. Here let's suppose like I think I have shown you like this one, right? Relay agent. Relay agent. What do you mean by that one? What do you mean by relay agent? Mhm. Okay, now what exactly this one is? DSP spoofing is a network attack where a malicious actor sets up a rogue DSP server to provide an incorrect IP configuration to clients. So this attack can lead to security breaches, connectivity issues, and the interception of a traffic. Let's suppose like we have a network. Okay, in this network we have our own legitimate server. Legitimate TCP. Legitimate means what? Trusted one. Okay, it's a trusted IP, sorry, the DHCP server we have, and an attacker like what? I don't know. Huh? Uh, like him, okay, he'll come and he'll connect his own DHCP server into the network. Okay, it's a rogue DHCP server. It's called as what? Rogue DHCP server. Okay, and he'll be configuring his device in such a way that if any PC they will try to assign or ask for or discover for that DHCP server inside the network, then obviously you already know that the DORA process, how the DORA process works. What is DORA first? Discover, offer, request and acknowledge. Okay, first it will generate a DORA process. So DORA is what? It's a unicast packet or a broadcast packet. discover is a broadcast packet or unicast packet? It's a broadcast packet. So it will go to everyone. It will go to here, here, okay, here and here also. Okay. So this rogue DHCP server is going to accept that request, and he is going to, before the legitimate server giving back to the reply, okay, before that only it's gonna reply back to the PC here. Okay. So that means this will be giving its own IP address to this one. That means every traffic which is going, this PC seems that what? Yes, I am connected to the exact DHCP server. Okay, I got the exact IP address what I want in the same network. Okay, but it will be getting, so let's suppose this is into 192.168.1.0 network. This is my legitimate IP address. And this one, yeah, I said like this is my rogue DHCP server, which is having 100.1.1.0 network. Okay. So what he will do, he will immediately offer a message whenever he get a discover packet or a discover request from this client. He is going to immediately offer the IP address, and this PC doesn't know whether it is a legitimate or a rogue DHCP server. It's going to assign that IP address on this one. So that means if this PC wants to talk with any kind of a outside network, okay, let's suppose this DHCP server is again connected with a one more ISP. Okay, he may be connected with the other internet ISP or something, and he will be giving the same gateway to this PC also. If he wants to talk with this other world or internet, then what he has to do? He has to go to the default gateway only. Okay, then he'll go to the switch, and he will not go to the actual default gateway. He'll go to the is assigned DHCP, sorry, default gateway, which is assigned by the attacker. Okay, so whatever the transaction is happening between this default gateway and the actual PC, he can monitor everything. Okay, even the sensitive data will also be captured. Okay, so that again lead for what? Same thing I said you, social engineering or exploitation. Yes, so this is called as what? DSCP spoofing. So here what we are doing, a malicious actor will be going to set up his own DSCP or rogue DSCP server. Okay, I mean whenever the client device they try to get the IP address from the legitimate DSCP server, that will be given to the rogue DSCP server as well. The request will be going to the rogue DSCP server. Yes. So rogue DSCP server is going to immediately assign or offer one IP address. Again, this request and acknowledgement that will be taking place later. Okay. And after that, which will lead to what? This attack can leads to security breaches. Yes, obviously security is breached here, and then connectivity issues and interception of the traffic may happen here. Yes, interception of traffic means what? Every traffic which is coming from, I mean, between this gateway and the PC, everything will be monitored in between here on the DSCP server. Okay, with the help of some monitoring tools. So how exactly it works? The attacker connects a rogue DSCP server to the network, and the rogue server is respond to the DSCP request from the client faster than what? Legitimate server. Okay. And the attacker provides the incorrect IP configuration. So I hope you already know that with the IP address, it will not only come with the IP address. It will come with what? It will come with the default gateway also that is going to be directing the traffic towards some malicious device, and it will be coming with some DNS server IP address also that will be redirecting the traffic towards some phishing websites. Okay, and the IP address conflict may happen, like it's going to disrupt the normal operation. Yes. So how it's going to impact the spoofing? I mean, how it's this spoofing it's going to impact the network here. So it's kind of a man in the middle attack, like he is going to intercept and manipulate the whole traffic which is coming from this PC towards a default gateway. Okay, and a denial of service, like it's going to disrupt the legitimate network operation by providing invalid configuration. Okay, he is going to give his own IP address and the default gateway and the DNS IP address and the subnet mask, everything. Okay, so where it is leading to some other network, some phishing website also. Okay, so phishing means what? It's going to redirect those users to malicious sites using some fake DNS servers. Clear? So just to mitigate this one, we have, I said, we have a method called as what? DSP snooping. Yes. So what is this DSP snooping? It is a security feature that prevents a DSP spoofing attack by acting a filter between DSP client and a server. What it's going to do? Here we are going to define some 2 port roles. One is what? Trusted port and untrusted ports. Okay, wherever there is a legitimate server where it is connected, that port is configured as a trusted port and remaining all as configured as what? Untrusted ports. Clear? You can see the same here. Trusted and untrusted classification will be done. I mean, trusted ports will allow the DHCP message from the legitimate server, and untrusted, they are going to block the rogue DHCP message from the unauthorized devices. So this is how we are going to mitigate the DHCP spoofing. Yes. So the switch inspect the DHCP traffic and filter out malicious messages based on the port roles here, or whatever the port level you are given, the trust or untrusted level. On based on that one, the switch is going to inspect this one. So the request I'm getting or the response I'm getting, I mean the offer message, okay, is it coming from the trusted port or from the untrusted port? If it is coming from the trusted, then it is going to take it and it will be given to the PC. If it is coming from the untrusted, then it is going to drop the offer message there on. Okay. So some key features of this one, it's going to maintain the DHCP snooping binding table. So remember this one, DHCP snooping binding table. So in this one, it will be maintaining what? It's going to track the legitimate DHCP leases like IP to MAC to port bindings. IP, MAC, port bindings, it will be there in the DHCP snooping binding table. Okay. And the same binding table will be used by the DAI. dynamic ARP inspection. Okay, here filters DHCP messages like DHCP offer or DHCP acknowledgement on a untrusted ports. Okay, so I hope you know that DHCP offer and DHCP acknowledgement will come from the server, and DHCP discover and the DHCP request will come from client end. Okay, if the switch is getting any offer and the acknowledgement from the any untrusted port, it's going to block their own. It's not going to tag that one. Okay. So next we have ARP poisoning or ARP spoofing. So what is this now? ARP poisoning is nothing but what? Here it's a type of a cyber attack where an attacker is going to send a falsified ARP message onto a local area network. The goal is to associate the attacker's MAC address with the IP address of another device, such as what? Default gateway, to intercept, modify, and disrupt the network operation. The same thing I'll take. So let's suppose like we have a PC here inside the network. Okay. So 3 PCs are connected and attacker is sitting here. Okay. Attacker. Yes. Mind it. Okay. Yes. So, Jeet, ARP is a broadcast message or a unicast message? Broadcast? Are you sure? Are you sure? Okay, when this PC wants to talk with the internet, at that time, first thing what it has to need, I mean, it want to need what? Learn. It want to learn the MAC address of the default gateway. Okay, for that one, what it will do? It will generate the ARP request packet. ARP request packet. So this PC will generate the ARP request packet, and that will be what? That will be the broadcast packet. Yes, it will go to everyone. So what happened in this time? This PC, okay, he is a attacker's PC, and he is going to know what is the IP address of this PC. Knows the what is IP address of this PC. And before coming into the network, he is going to assign the same IP address on his system. And after that, he is going to connect to the network. Okay. So after connecting, once the broadcast packet reaches here, he is going to give his own MAC address as what? Default gateway's MAC address. He said that this is what the default gateway's MAC address. He is going to reply back to this PC. Okay, this is the MAC address of the default gateway. Okay, so you can keep this one in your ARP cache. So that means whenever this PC wants to talk with the internet, it has to go through what? Default gateway. So instead of going directly to the default gateway, he's going to attacker's PC. Okay, and then on the attacker's PC is already given the gateway as this one, and he already know the MAC address of that one. That means whatever the traffic is going, I mean, before directly going to the legitimate gateway, it will go to first attacker's PC, and then it will go to the default gateway. So that means again, it's kind of a man in the middle attack. What he is doing? He's just monitoring every data between what? The same gateway and the PC here. Okay. You can see. So what is this? Here attacker is going to send the falsified ARP message onto a local area network. Okay. So the goal is to what? Associate his, attacker's MAC address with the another device. Same thing he has done, right? He has given his own MAC address as a default gateways, and it will be associated with this PC. Yes. So in such, such as what? Default gateway, or to intercept or modify or disrupt the network operation here. Yes. So how exactly it works? Here ARP is used to map an IP address to MAC address within the LAN. You already know that. Yes. So the attacker sends a forged ARP messages to the devices in the network and redirecting their traffic to the attackers. What's happening here? He's forging, he is giving his own MAC address to this PC, and all the traffic of this PC, which is redirected to this attacker's PC. Okay, from there it is going to reach the gateway here. Yes. So what will be the consequences of this one? So first one is what? Man in the middle attack. Like attacker is going to intercept the communication between the devices here. Yes. And the data theft or a sensitive information can be captured, obviously, because he is going to use some capturing tools. With the help of that one, he is going to capture or theft all the data from this PC or the user. Next is denial of service, like a network communication can be disrupted, and the session hijacking may happen. Okay, that is like active session can be intercepted and exploited. Okay, so how to stop this one? Again, you have to do the same. What is that? You have to define the trusted and untrusted ports here. Yes. So the prevention will be like DAI, dynamic ARP inspection. Okay. So it uses a secure protocols like a HTTP, yes, and the secure shell, where it is going to monitor and log the ARP activity to detect anomalies. Okay. And how exactly this works? Dynamic ARP inspection is a security feature implemented on a network switches to protect against some ARP poisoning attacks. Okay. Where it works by validating ARP packets within the network based on the trusted database, that is IP to MAC address mapping, typically created on the DHCP snooping binding table. That's what I said. This snooping binding table will be used by this DAI. Okay. Whatever the port is trusted, from there only it's going to take the request. Otherwise, it will not be. Okay. So it's going to validate the process like what? It's going to inspect our packets to ensure they match the legitimate mapping. Because what I said, already the PC, okay, whenever the first PC try to ask for the IP address, the DHCP will be maintaining what? The DHCP snooping binding table, where it will be having what? The IP address, and to this, this IP address is assigned to which MAC address on which port. Okay, it will be there. Yes, and obviously the MAC address will be different for each and every devices. And for 10.1.1.1 is already given for what? AA on the port number faster than 0/1. And now this ARP message is coming from, it said like I'm also 10.1.1.1, but you can't lie with the MAC address. MAC address will be different. Yes, so that is not there in my binding table. In that case, it's going to inspect the snooping binding table. If it is not there, if it is not matching with the snooping binding table, it's going to drop the packet there only. Okay. Okay, what I said, it's going to inspect R packets to ensure they match legitimate mapping stored in the DHCP snooping binding table. Yes, if it is matching, it's going to take, or otherwise it's going to drop invalid or a malicious R packets. Yeah. Again, the configuration will be like what? DAI is enabled on the untrusted ports, those connected to the user ends. Okay. Okay. What I said, it's going to validate what? The DHCP snooping binding table. And if it is matching, then it's going to allow the traffic. Or if it is not matching, then it's going to drop the invalid or a malicious ARP packets there. Okay. And it will be enabled on the untrusted ports. Okay. I mean, those which are connected to the user devices. And the trusted port will be like a uplink or a server connections where I have to bypass the ARP inspection. Why? Because there also, if you make that untrusted, then it's not going to get the ARP reply packets. Okay, so that is the reason you have to make those interfaces as a trusted ports. Clear? So what's the benefit of this one? So it's going to prevent the ARP spoofing or poisoning and protects the integrity of the network traffic and enhance the network security. But there's a requirement, I mean the limitation. What is that? This configuration needs the proper configuration of the or maintenance of the DHCP snooping. It what? It has to be properly configured with what? The DHCP snooping binding table. Okay. So configuration is nothing. I think I already have this one here. Yeah. We'll just keep that attacker space for now. We'll just take a
About the lecture,
yeah.
can you please ask